All right, geometry. Here's some problems involving reflections. So problem 1 says, what is the image of -9, -4 after a reflection over the y-axis? So when you reflect over the y-axis, this is the rule. The point xy becomes opposite of x, opposite of y. So we're going to take this point -9, -4, make the x opposite. So the opposite of -9 is 9, and then the -4 stays the same. And there's the coordinates of that reflected point, 9, -4. All right, next problem is coming. Okay, next problem here, it says, what is the image of 8 to -7 after reflection over the line y equals -x? So this is another one of our common lines of reflection. Remember that when you graph across the line y equals x, the point x comma y becomes opposite of y, opposite of x. So your x and y switch places and the signs become opposite. So the -7 will come first and turn positive. The +8 will go second and turn negative. And there is your new point, 7, -8. There we go. Okay, next problem coming. Okay, so this problem says determine the line of reflection that would map the pink figure onto the dotted outline of the image under the reflection. So it says click and drag the yellow dots to change the line. Click and drag the line itself to move it parallel. So we would like the pink figure to go onto the dotted figure. So when you move this line, notice the blue figure moves. So somehow, some way, we have to put this line of reflection. So the idea here is, and I'm going to put it right up here. So okay, is okay. If I connect, and I hope you can see what the corresponding vertices are. If I connect this point to this point, right? So this would be like A, and that would be like A prime, right? Where would the line have to go? Well, I hope you can see that it has to be perpendicular and go through the midpoint. So there's 1, 2, 3, 4, 5, 6 in between these 2 points. So 1, 2, 3, that would be the midpoint to make this segment congruent to that segment. And it has to be perpendicular. So I hope you can see that this is where my line of reflection is going to go. And you'll see that as I drag this down, I'm going to put it right on top of that blue line. And there you go. And notice that the blue figure, right? If I take a look, I got it right. So I said I'm done. But the blue figure went on top of the dotted figure. And again, you can see that it goes directly across that line. That line is the perpendicular bisector between the pre-image and the image points. Let's do one more of those. All right, so let's try this one. So same idea. We have to determine the line of reflection that will map the pink figure onto the dotted figure, okay? So I'm going to slide this out of the way for a second. So again, now I hope you can see that the corresponding vertices, so say this is A, and say that's A prime. So now it's diagonal, right? So the line of reflection is going to also be diagonal. And it's probably going to go right around through here, which looks like the midpoint. Let me do that in red. Right? And it's going to go somewhere like this. So again, this is experimental. So we can use the line and move it around to where we think, but I think it's going to be like that. The other thing to understand is that since these lines are perpendicular, their slopes should be opposite reciprocals. If you look at the slope of this blue dotted segment, it's going to go up one and left one, up one and left one, up one and left one. That's a slope of 1 over -1. That's a -1 slope. So the red line should have a slope that is the opposite reciprocal of -1. So the slope of the red line should be +1. And look, if I start here and I go up 1, right 1, that's pretty close. Okay? So I'm looking for a line with a slope of 1 passing through this, what I think is the midpoint. It could be a little bit closer, I suppose, but right around there is the line I'm looking for. So I'll go ahead and move the line down here. Let's see. All right, so let's keep changing it. Oh, there's the yellow. Okay, so it looks like it's going to line up there. So now I just have to drag the line. See how I kind of have it aligned correctly? So now just drag the line. Oh, I got to turn it just a smidge. just a smidge this way. There, look at that. That's perfect, right? See how it's right? And it says you are correct. So again, as I said, it's going to go right around through here, the midpoint between those two, the midpoint of the segment between those two corresponding vertices. And notice your slope is positive 1, up 1, right 1. So those are tricky. Just play around with them though, all right? It's very nice how it has the lines on there for you and everything. All right, a couple more problems. All right, so let's take a look at this problem here. So now we need to find the line of reflection going between these two, right? So this is follow the guided instructions below to create the line of reflection that would map the pink figure onto the blue figure. Click and drag to draw lines connecting all corresponding points from the figure to its reflected image. So the red figure, the pink figure is first. So take this, drag it to its corresponding vertices. So I believe that's corresponding. I think that this one is going to be corresponding to this one and this one to that one. Right? Okay, so I did that. So now it says plot all the midpoints of all the dotted lines. So I'm just going to kind of guess, right? So I think it's like here. Let's see. This is maybe right around there. And then this one right around there. You can count the slope if you want to. So each of these has a slope of up 1, right 1. So you could do that each time. So like say the middle one was tough to see, right? So you could say, okay, how many slopes do I count? Up 1, right 1, up 1, right 3 or 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there were 14 slope counts. So now count 7. 1, 2, 3, 4, 5, 6, 7. I counted it. There's the midpoint. Okay. Now it says draw a line that goes through all the yellow midpoints. There we go. That is going to be your line of reflection. Look at that. So now it says, what is the slope of one of the dotted lines? Well, the dotted lines are the segments joining the pre-image to the image. So they're going to have a slope of 1, up 1, right 1. What's the slope of our reflection line? Well, remember, they have to be perpendicular, right? So if the dotted lines have a slope of positive 1, the solid line is going to have a slope of negative 1, down 1, right 1. And now it says, what is the equation of the reflection line? So it's going to be slope-intercept form, y equals, since our slope is negative 1, it's going to be negative x, right? And now, what is the y-intercept? Where does my line cross the y-axis? At plus 1, right there. And there's my y-intercept. Try that. Oh, yeah, I'm correct. Nice. Okay, last two problems coming. Okay, so this one here is a reflection where you're going to graph the actual reflection of this triangle. Now, this is over the line x equals negative 3. You're very lucky they drew this line for you. X equals negative 3 is a vertical line. So in order to do this, since my line is vertical, that means that all of the lines connecting my pre-image with my image will be horizontal. So for instance, if I choose this point down here, right, if I connect those, right, I know that my image will be somewhere on this line. And it has to be the same distance as this is. This is a distance of 2. So my image must also be 2 away. 1, 2, right there. And that is going to be the segment connecting your 2 points. It's perpendicular to your line of reflection, and those two distances are congruent. So it's simply counting in the perpendicular direction. So we're just going to simply count. So again, I'm going left to right. 1, 2. So do 2 more. 1, 2. Same distance away. This point right here. 1, 2, 3, 4. So count it again. 1, 2, 3, 4. This point here. 1. So count it again. 1. And there's your reflected triangle across that vertical line. Submit my answer. Don't mind if I do. And look at that. Look at the animation they do for that. So if your line's horizontal, you just simply count vertically across that line. All right, last problem coming. Okay, so now we're going to reflect over this line. This is a line y equals negative x minus 1. So this is a little bit more tricky, okay? Again, the slope of this line is negative 1. Negative 1. Negative 1. So I can do that a whole lot better, right? I can write negative 1 a whole lot better. Yes. So now all of your lines connecting your pre-images to your images will have a slope of 1. Okay. So from here, we're going to go down 1 and left 1. That's going to be a -1 over a -1, which is a +1. So if I think about, and I'll do it in red, right? Down one, left one, down one, left one, down one, left one. This line here is going to have the image of this pre-image on it. So how do I do that? Well, we're going to count slopes, right? If you count the slope from here to the blue line, down one, right one, or down one, left one, that's one slope. And then if I go down one, that's 1.5 slopes. So what I'm going to do is I'm going to finish that slope. There's my half, and now count the slope. Down one, right one. There is where your point's going to be at -2, -2. All right? At -2, -2. So I'm going to erase that, and I'll put a point at -2, -2. Okay? I'll do the same thing with these other lines. So again, I'm going to count the slope. Down one, left one. 1, 2, 3, 4, 5.5. So finish it. There's your half. 1, 2, 3, 4, 5. There is where that point's going to go. Right there. Last time with this point, count the slope. 1, 2, 3, 4, 5, 6, 7. So it landed evenly on the line. So now count 7 more slopes. 1, 2, 3, 4, 5, 6, 7. And there is the other point. Boom. And there you have it. There's my line, my triangle reflected across that line. And again, I'm using the idea they're showing you, right? They're showing you that if you connect your vertices, so say A to A prime, it's going to be perpendicular and equidistant to the line of reflection. All right, good luck on these problems. If you have any questions, please ask for help. Reflections do step it up from translations. So I understand you need some help.